We're back at Honors Algebra 2 Pre-Calc, doing Pre-Calc section 9.3, which is geometric sequences in series. So we're going to talk about the sum of a finite geometric sequence. So by that, we actually mean a finite geometric series, right? Because the only difference between a sequence and a series is whether you're adding or just listing the numbers. And here we're adding the numbers. So the sum, S sub n, is meaning the sum of these geometric things from the first term to the nth term is given by the first term, right, a sub 1, times, in parentheses, 1 minus the r, the common ratio, to the nth power, which is whatever the sum you're going to, so the 10th or the 100th or whatever power, over a 1 minus r. So essentially, to find the sum of a finite geometric series, we need to identify a couple things. We need to identify the first term, we need to identify what r is, and that's about it. And we need to know what n, like what the top value of a sequence is. So for example 5, we're going to find the sum from 1 to 10 of a 5 times a 0.2 to the n. Now, a thing to be mindful of here is notice how this is the power r to the I minus 1, right? Not just r to the I. So the issue here is that the first term is not a 5. If you write out this sequence, right? So you don't have to write out the whole thing, but if you write out the first couple terms in this series, what you're going to notice is the first term is a 5 times a 0.2. That's your first term when you plug in n as 1. And then the next term is going to be a 5 times a 0.2 quantity squared, right? So what I want you to notice is my r is definitely the 0.2. My r is definitely 0.2, and that's fine, right? But the first term, a sub 1, is a 5 times a 0.2, which is a 1, right? So I need to recognize that the first term is not a 5, because if you plug in the first value, you'll see that you don't end up getting a 5. If this had been an n minus 1, your first term would have been a 5 times this thing to the 0, which would be a 5. So once I know that, right, plus dot, 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 I don't really care, right? Once I know that that's the setup, I know that I need a1, right? So a1 times 1 minus my r to the n over 1 minus r. Well, in this situation, my a1 is a 1 times 1 minus a 0.2 to the 10th, right? And I don't actually need the parentheses because the 0.2 is positive. So 0.2 to the 10th divided by a 1 minus a 0.2. Now, when I put this in my calculator, because no one's ever going to expect you to do this by hand, when I put this in my calculator, this is what it's got to look like. You don't need the 1 necessarily because it's a 1, but if it had been something else, I need 2 sets of parentheses. I need one for this entire big set of parentheses, and then I need one to be the parentheses around the numerator, right? So parentheses, 1 minus 0.2 caret 10. Now technically that 10 is in parentheses because that's the way our calculators do exponents, and that's fine. It's not going to matter a whole lot here, right? Divided by, and then I need another set of parentheses down here for my denominator, right? Because that's the only way to ensure that subtraction happens before the division, right? So that's what it's going to look like when I put it in my calculator, right? And when I do put it in the calculator like that, you're going to see that I get 1.24999, bunch of 9s, and then some other stuff later on. So when I round to my 3 places, as I invariably should, I get 1.249, or if you're rounding, not truncating, you'd get 1.250. Either of those are fine. Now what we're going to talk about shortly is when we find the sum of an infinite geometric sequence, because we could actually find the sum of this thing for infinite terms, not just the first 10 terms, and when we do, we're actually going to get a 1.25, and we'll talk about that as we get closer. So that's sort of the gist of how you find the sum of a finite geometric sequence. So again, really all a geometric series is essentially all of these. It's essentially a sum of a geometric sequence. So that is example 5.